Okay, now then that the manual installation and the installation that actually made by the Docker container, where you just run the Docker container, are out of the way. I now want to talk about the RETI-Debugger plugin itself. Yeah, maybe first of all concerning something at the end of the last video about the manual installation. There was a stupid bug that was actually in this, because it was in all the NeoVim version. That that's a bug that I won't fix, because it was an old bug that is by now fixed, and that's why I'm not going to fix it, because it works in the new NeoVim version. And yeah, by the same time Ubuntu will also ship the new NeoVim version, and that's why that would be a waste of time to fix something that will anyways be fixed in a later version that will by the same time also ship to Ubuntu. So now I want to start this image. I just wanted to show this bug again. Now I start this image again, and this bug looked in the following way. If I open this, then compile and start, and this was a bug that you can already see it. Normally I would focus, and then this window should stay in this position, but it does only stay for one moment, and then it swaps again. And that has something to do with the NeoVim API. And it didn't immediately execute it, and then there was it doesn't execute it because there's immediately another command after that if you look it up in the code. And and that's why it doesn't. This middle window here should actually stay in this position, but it doesn't stay, and that's a little bit problematic. But this bug I won't fix. It has something to do with how the cursor was handled and back then, and if the cursor wasn't in the window, really in the window, and then it wouldn't update the window, and something like that. You already see how it handles. That's a little bit unfortunate, but that's something I won't fix. Now both windows. Actually have to. But the auto-scrolling mode works, and auto-scrolling mode works perfectly. But as you can see soon, in the newest NeoVim version it's working perfectly. All on this one, and but fortunately it works perfectly fine in the new version. Oh, and another thing I wanted to show is in the last recording there was some things not updated, but now everything is updated in this documentation. Key bindings, and now the key bindings are all with R. And that was, I guess, the only mistake in the last. And also here is everything also with R, and the map leader is added. Now everything is up to date. Maybe I change it up to show how it works in Ubuntu and not Arch, but only if I find time. But it can, I guess it can be seen in the last recording. 2 with number 2. Yes, and luckily this bug is in NeoVim itself is fixed by now, and of course in the new version everything works perfectly fine. I actually have to say the custom init.lua is by now fixed to work with R, but in my own config it's actually still with P. So I change it to P, and yeah. And yeah, maybe I activate screen key again. And yeah, now I can just show I just show the plugin as it is. Yeah, I just give an overview of all features of a plugin. Yeah, there are these commands: load RETI example, that just opens the menu, and it just does this exactly same as I think I really kill screen key. All screen key. I guess you can follow by just following along with this manual. There you can see all the key bindings, and yes, and so we have here RE, for example, space RL is going to open this list here of different programs that you can try out. I can choose this one, and it just does the same like load RETI example without any arguments. But you can also, of course, specify arguments. Load RETI example 13, and then it's just going to open up the 13th entry in this. 2, 3, 8, 9, 10, 11. Oh, it always skips about the entry that is currently open. Oh yeah, that's the reason why I miscounted in the previous video. Yes, and then one can compile it. One can either use compile PQC buffer, or one can use the key binding Control R C. It's also going to do the same. If I now hit C, it will show an error message because it can also only compile PQC to RETI assembler. It can't compile RETI assembler to RETI assembler. That wouldn't make any sense. And that's why it shows the error message in this error message buffer pop-up window. Yeah, and now I can already come to this section here. And the error windows can be closed in many ways. So that's in this section here, pop-up key bindings. And yeah, you can either close an error pop-up window by just clicking with your mouse outside of this buffer, then it will disappear. Then you can just hit Q, then you can hit escape, and then you can also hit enter. Now we start the plugin with now we can start the RETI-Debugger. It will mount a window and start the RETI interpreter in the background. So we can copy this command. Yeah, okay, I could just write it out because I have auto completion. start RETI buffer, then it's loaded here. And you see this bug is fixed here in this new NeoVim version, because new version, and you see this window that stays in the same position all the time. That's actually a pretty interesting example, because I guess it calculates all. I think there was a more interesting example. No, there was what example, and I guess Fibonacci efficient was it, I guess. No, I have to compile it. You just saw another error window. That's because it's actually loading my Neo tree here, but this here should also not work, because the RETI-Debugger can of course only send a does also of course only display RETI assembler code and not PIC code, and debug it. It can only debug RETI interpreter, RETI assembler code, and not PIC code. So we can now choose any way, many possible ways to quit out of it. I choose Q, and now I compile it and run it. Yeah, and I guess this example was quite interesting, if I remembered it correctly, because here you could see, I guess this it executes it calculates the Fibonacci numbers, and now when it goes back, you see how slowly the different Fibonacci numbers display there as return value. If I remember correctly, 5, then the next should be 8, yes, then next should be 13, and how far does it, 21, and 33, 44, and at the end 55, the Fibonacci numbers. You can also restart it. That's about the normal commands here. Then you can of course hide the layout with Control R H. This key binding does only appear after starting the RETI-Debugger. It's not available from the start, available up from the start, but it's still a global key binding, because you also have to be able to use it outside of this windows here. And this commands also have their representatives in RETI code. And now you saw something else, that the RETI-Debugger was still running, and in this mode I of course can't start it. If I hit this, it just does nothing, and that's because of the state machine that I implemented. And in this state machine, it's if I go to if interpreter is not completed yet, it's not possible to it's not possible to start it, because you see here there's no edge from here, there's no start edge from here, and it first has to complete until I can actually restart it, and I only can start it once I quit out of this window layout, and the window layout is not visible anymore. Then I can start it again. Then the only other option is that is to restart it, I can restart it also if the interpreter hasn't completed, and also if it has completed, I can restart it, as one can see here. But I first have to quit out of the window layout once it has completed, if I want to start it again with this R space RS that starts it. And yes, I guess the other key bindings is something I already have shown. Load and yeah, compile. Compile. Let's start. Yes. Now I go back to the key bindings. And yes, then of course, as you've already seen, yeah, there's also this input window, and in this input window it's not possible to execute next. You see that's the if I go out into normal mode and execute next, it's not going to execute the next command to execute the next instruction, but it executes the normal if search command. And the last thing I searched was load, and it can't find it, that's why it displays it. Yeah, then another interesting thing is that here you can't type in any. I can quickly open screen key again. You see, if I type in a number, it's working, but as soon as I type in something that isn't going to be a number, can't come out as a number anymore, then yeah, it won't work. Yeah, it really has to be a number. Yeah. I guess I already talked about the different ways to exit out of this windows. Yeah, for the output window, it's also the same as for the error window. You can use Q, escape, or click out of the window, or you could use enter. I use enter and it closes. And yes. And I quickly restart. And another interesting thing is that while I'm in this window, I can't execute the next command. And I also can't execute restart. Or I also can't hide the window layout. No, it doesn't work. I first have to yeah, quit out of it. And also if I click here out of it, yeah, next command won't work, even though I am in this buffer. And also restart doesn't work, and yeah, none of the commands works until I quit out of this window here. Or until I submitted something. I actually can't quit out of it. You have to submit something. And if you submit nothing, then it will be 0 by default. In case you just want to get some default value that works in most of the cases. And the reason for why it doesn't work, because once you open a pop-up like the error window or a input window or a error or output window, and then in this case it's not possible to use the next command anymore. And yes, and from this command also you can't hide the window, as we've seen previously. You can only hide the window once no pop-up is visible. And then you can hide all the window, the whole window layout. But from this state here, it's not possible to hide or use hide or show. And yes, and also next is blocked. And yeah, I can't go into all the details of this diagram, but yeah, you see the basic principle. And only from this state, if the interpreter it hasn't completed, it's possible to use next. This next command. Yeah, and you see now it is possible again to hide the window once I am out of the pop-up window. But within this pop-up window, it's not possible to execute, to hide the window. Only now again. And it was also not possible to use the next command, even out of the window. The next command is the N. Okay. Yes, and all these windows have been implemented with this NUI library. So yeah, credits go to the authors of this NUI .nvim library, with which I wasn't affiliated. And then yeah, then there's of course therefore I quit out of the window and open this example again, compile it. Oh, it is already I already compiled it. Compile it. Yeah, now it is compiled. And here I can, with the M key, I can switch between mode. That's the auto-scrolling mode, and you see how it works. Here it is 88, and it continues with 89, and here is 127, and it continues with 128, and it scrolls all windows synchronously. And also if I go into any of the windows, they will all scroll synchronously, as long as no the start or as long as it doesn't bound to the end of the start of the buffer. Yeah, but they all scroll synchronously, as you see here. But yeah, memory focus is mostly what you want. That's why it's also the default option. And yeah, and for this menu window, there are also separate shortcuts, and these shortcuts, yeah, you can go up and yeah, for this menu, of course, you can't see it, because there are only two options, and one is always blocked, because that's the current one currently selected. But as soon as I implement more options, that will work out. But you can see in this menu, yeah, you can go up and down with JK, with arrow keys, with tab, with shift tab, with M, with shift M. You can quit out of it with escape, you can quit out of it with Q, and you can submit something with enter or space. Yeah, that's and, yeah. You see, I try to make it as convenient as possible, because later students are going to use it in the best case, and yeah, that's why everything should work fine. And of course, in the input window, you should have your type, or maybe I should also add here space. I will add it later to submit a value. Yeah, but yeah, you submit a value with enter by at the moment. If I don't forget to add space, that's yeah, something I could also add. Yeah, and now to buffer key bindings. That are the key bindings that only work within the buffers. They override global key bindings, because as you have seen with this, when I open this input window and hit N, then it executes the normal N command in normal mode for NeoVim, and that is to go to the next match where the search pattern matches in this search. But here this N is over this buff. As long as I'm in the buffer, this N key binding for normal mode overrides the Vim default key binding. And yeah, that's that's why it executes this here. And then if but if I'm outside of it's no R. I was still used to PH, but it's RH. But here, of course, this I have last search for load, and then it this N is as usual. So this key bindings here only work inside these buffers that have these key bindings, and not outside of these buffers. And they are overwriting global key bindings. So yeah, I can switch. And all these key bindings are buffer exclusive key bindings, and they will only work in these buffers of this window layout here. Yes, and then I shift tab, I can move around in the windows, forward and backward, forward with tab and backward with shift tab. Then I can of course open up the menu and switch between these modes. Yeah, and another interesting thing is that if I can move this to windows. Oh, and another interesting thing is that if I go to auto-scrolling mode, this titles here change. Auto-scrolling is just a normal SRAM section, and here it's just this displays the start of a data segment in memory focus mode, and here is the end of a data segment. And now interesting thing is that this, if I go into memory mode, if I go from auto-scrolling to memory focus mode, then this memory focus only works in the first round, and then after this round it won't focus it anymore. I have to hit the F key to focus it again, and that's due to this state machine, this other state machine here. Yeah, in the first round I actually have to add here something that has to be changed to next, or as soon as the memory focus mode has changed to something, yeah, you can execute it once. You can execute as soon as you change to memory focus mode, you can execute it once. And then after that, the first focus is over, then it won't focus it anymore. And you have to hit the F key to focus it again. And that's made by this state machine. And yes, then of course there's this menu to switch between modes. You can restart with the RETI-Debugger with R, either if it has finished or if it hasn't finished yet. There's, I guess, a little bug why it is in this example, why it finishes already here. Yeah, but it's kind of convenient that it's actually the case. The RETI-Debugger with interpreter stops here. And yeah, and of course you can quit out of the RETI-Debugger, and then you can and only once you quit out of it you can start it again. Before that, the start command won't work. You have to quit out of the window layout first. Yeah, that's something I have to look into later. Yeah, but as you could see, yeah, I can restart when the interpreter it has kind of completed in some way, and also when it hasn't completed, just like in this state machine. Can restart here, and I can restart here. And yes, and now I want to go into some implementation details, how this whole protocol works, because you see the RETI interpreter is started and also finishes at some time. And here's how the protocol, and I somehow have to exchange data between this RETI interpreter plugin. I have to exchange data between this RETI interpreter, RETI-Debugger Neovim plugin, and the RETI interpreter. Yeah, the implementation is basically here, and yeah, and the protocol looks the following way. First, either the buffer is sent to the RETI interpreter, and then there are several possibilities. You see this that shouldn't be the case. Please close. Yeah, I start this example here. And then the protocol looks the following way. It sends the registers that are these registers that you see here, or it makes a output message. That's the case if it stumbles on a call print command. Yeah, maybe I choose another example. Yeah, if it comes to a call print arg, then it sends registers, and optionally, that's why there are these parentheses. It also sends in the same row. It sends this the output message, and yes. But actually, it sends first the output message, and then in the same address it sends registers. And then yeah, the other possibility is to have a input window. Then it makes a input request, and then you send the input plus a acknowledgement input, and then yeah, it's kind of with this asynchronous library, libuv, and that's how it works. And yeah, it kind of that you send both. Or actually, if I remember it correctly, is there actually an acknowledgement? Oh no, there's actually only an input, no acknowledgement, if I remember correctly. Yeah, basically it's implemented by this. You're kidding me. by this chain that you see here. I haven't seriously caused a bug. Yeah, anyways. In this Arial plugin, yeah, it's basically implemented by this chain, and if a input is if here in this data, it's kind of an asynchronous Vim loop is this libuv library, this love library, that's this port of libuv. That's this port of libuv for Lua. It's called love, and libuv is yeah, this documentation here. And it's an asynchronous library to execute things asynchronously. And then there's this chain of command, this chains where this functions write something, this acknowledgement, and yeah, but here's actually no UC. Yeah, that's a mistake that I still have in the documentation. There's actually no accent. It checks for previous outputs, and there, if there's a input, then it makes this input, yeah, it changes the state machine to a pop-up appears, as it can be seen in the documentation. Pop-up appears, and then there are these different cases, and then there's this output, this input case, and it asks for input, and there it yeah, it mounts the input window. In the input window, I guess the input window is yeah, the input window, yeah, there's this blocking of non-numbers, and then in the input window, once it's submitted, it's closed, and here it writes, it just sends the value I submitted. So yeah, there is no UC. And yeah, and then yeah, so I have to so here this input plus UC is wrong. It's only an input. That's something I have to change in the documentation. And yeah, and once this ask for input has finished, it returns nil. It returns nil, and yeah, and returns to this function here, and then and if there's no because it returned nil, it returns here, but then it kind of still that's the way how this read start function is implemented. It kind of just still off. So Vim loop is kind of the same as libuv. You can just replace it by uv or some yeah. Can make something like local uv is equal to Vim loop, and it's kind of that. And it's called kind of in the documentation. It's always called uv. Yeah, it's kind of the same like libuv. That's all the different many different functions from libuv, but actually from love, that's this Lua port of libuv. Not port, but yeah, API, called the API of libuv, I guess. And yes, and then it's still in this read. It returned from it, but that's the way how a read start function works. It's still reading, and then it will, as soon as the input is sent, that's that can be seen here. Not here, it can be seen under instructions, and here for the input, here is kind of the string that this input request is actually just this string here that is sent by the input function, and then it's just waiting here for the input, this input request that is sent by RETI-Debugger. That's this input here, and yes, and then it just goes on as usual. Then here this loop finishes, and then this in interpret RETI instructions, here the daemon just continues as usual, and then it just makes it just sends the then it just sends the usual packages as usual. Oh, I made another mistake. It doesn't send registers rel, but it starts here. Yeah, I have to make another error. In the final documentation it will be correct. And then it sends, it kinda goes here, and then it have to send registers again, and then acknowledgement. Yeah, that's something I have to change. In the final documentation it will be correct, but all other calls are correct this way. Yeah, and this input request is just the string that gets sent, that is called, and that's just this string here, input dot colon. It's just the string that you see here, and that's the string that gets looked up here. It searches for input in the received data, and the data received from the start read function. Yeah, this data here. And yeah, and then this chain just goes on. Update registers calls update registers rel. This rel is just are just these relative registers here. And these relative registers are just to make it more readable, because here they are kind of this is a little bit of implementation details of a RETI, but it's sometimes useful to know how it is without this constant added. But yeah, it would be too much details now. It's kind of because of this memory map, and with this memory map you can distinguish between EPROM, UART, and SRAM. And yeah, because of this memory map, yes, also is this constant here. And sometimes you want to know the value without this content. If it's an address, you want to know this value without this constant, because without this constant, then you get the address here like it's for these values. You can get the relative address relative to the start of the SRAM. Yeah. And yeah, and then this protocol just goes. Yeah. Yeah. I made all these windows actually modifiable, and also not read only, so you can. And the advantage is that yeah, you can basically save this buffer contents, and that's kind of quite handy sometimes. You can say you can copy this buffer contents or change them up or something. I guess there's no reason to forbid it, because if I change here something, if I change something about this Windows, if I make this a if I change this to or something like that, it will anyways be in the next iteration where I execute next, it will anyways be over. It actually notes the next content, and it will be overwritten, and not overwritten, but yeah, the next buffer replaces it. Yeah, and then this chain goes on, registers rel, EEPROM, UART, SRAM gets sent, and yeah, that's basically what you see here. No, you see here. Registers rel, registers calls registers rel, update registers calls calls EEPROM, this calls EEPROM calls UART, and UART calls SRAM, and so on. Yeah, it just continues this way. And yes, and then there's all this auto scrolling and stuff. And yeah, and because a little bug of it in the NeoVim API, I have to call this with pcall, but yeah, it would be too much details to go into it now. But pcall is kind of like try and accept in Python. Yeah, you call it, and if there's a error or something, it just continues. Yeah, and, but everything still, it's just an error to prevent an annoying error message that's because of a bug that isn't fixed at the moment yet in NeoVim. Yeah, and there's this, and you see this chain here, and it's always that in this chain you write an acknowledgement, and then this and then you read. Yeah, and that's just the functions from the RETI-Debugger. From libuv, this Vim loop functions. Write is and I always have to send this with a new line character, because this input from Python works with new line. That was kind of the best way to say it is now finished, and stop asking for input. The input is finished. That was kind of the easiest way to use this end function. And it communicates over the communication is over works with pipes. This pipes are created, and these pipes are sent to a and this the RETI interpreter or PQC compiler, the RETI interpreter is part of it, is started with the spawn function, and there this for standard input and output and error, this named pipes are used for. These pipes are used for. And yes, state machine, and that's the pipes that are used here to make this write and read. You write the standard in of this RETI interpreter process, and you read from standard out of this RETI interpreter process, and that's how this communication works with pipes. And yes, and here schedule wrap has to be used, because NeoVim is actually single threaded, and that's why you have to kind of schedule the right moment to be you can't execute it asynchronously as usual, but you have to wait to in this loop of NeoVim to a right moment where you can again execute something in NeoVim, but you can't execute it at any time. You have to write up to the right moment until you can make a Vim API call again. So if you have something here in this function, here that is called as callback function, as you see here, callback function, and this callback function gets called as soon as the reading has finished. Yeah, for example, if this is so annoying. This call screen key. I think that's enough of screen key. Read stop was the command. Yeah, and it only stops reading either if it's interrupted by another read or write, or if read stop is issued. Then it stops reading. Yes, and it collects data as long as there wasn't a new read or write that should that interrupts it or something, and that but the write is immediate. It's kind of always that two processes that interact with each other. The reading is always until some point, but writing is immediate. So it's not, it doesn't collect something or so. Just when you send something, if you receive something, you kind of collect it. And here it's it only stops with read close or if it's interrupted by a write. And for the RETI interpreter, it's as soon as a new line appears for the input. That's why I chose this input. And this writing of the RETI interpreter to standard out is just with normal print statements, as you can see here. Yeah, it's just a normal print. It's a daemon. I hate it. Yeah, it's just a normal. It's just a normal print statement. And here in the RETI, it just gets this string is spilled, kind of. Yeah, basically only this three files here are really important for the. Of course, I changed a lot in all files, but that's where basically all important things that where I extended the RETI interpreter to work with this plugin take place. And yeah, here you see this protocol. Yes. Yeah, here's this SRAM chain here. And yes, and it starts again as soon as it asks for input here, and then one can issue a command. At the moment there's only next, but I also want to implement a set command where you can change a register value while the interpreter is executing, but that's something for the future. At the moment it just waits for the next command, and then it starts again from here. And yes. Oh, and there's also a small protocol if I just want to There's also a small protocol if I just want to compile something. Yeah, if I just want to compile something, I send it to RETI interpreter, send it to a PQC compiler, not a RETI interpreter, but they're kind of the same thing. And then it returns error RETI code. It returns the RETI code, or it returns an error message. Yeah, and now I can compile it again, and then it's an error message because I can't compile RETI code. I only can compile PQC code to RETI code, but RETI code is already the lowest level. Okay, there's also still that's only RETI assembly that can still be assembled to machine language, but yeah. Yes, that's this protocol, and it's basically implemented over here. Display output, and now run compiler. It again uses the spawn function, and yeah, it basically just runs it. PQC compiler, and then yes, and then reads the buffer content, and yeah, and just sends this buffer content, then it just waits for a read. And yeah, then makes read stop, because then there's not all too soon another write or something. That's why I have to call read stop on the standard output, and yes. Okay. And then, yeah, one could actually start the real. Then after that, one starts the communication with RETI interpreter. Okay. Yeah. I also use different functions from LUV, this port of libuv to Lua. And yeah, there's for once there is there's for once loop new async that creates a async event, and this async event gets only executed once asynchronously once it's sent with async.send. That's used for this menu here, because I have to if I load an example program, what I want is that the problem is that if I don't make it async, that my while it hasn't received a input, it doesn't receive something to read, the editor will just be stuck forever. And that's why here I have to make this async send only as soon as I have chosen something in the menu, because else it would kind of be stuck in this window. Just the whole NeoVim instance freezes completely until it receives an input. But this input will only be triggered once I have chosen something in the menu, but I can't choose something in the menu because in the menu I'm just stuck. And that's why I have to make an async call that this whole function only gets executed. Why again? That this wall async function only gets executed, this wall block here only gets executed as soon as I receive something, or it gets executed if yeah, this is kind of a case if I this load RETI example command has no arguments, then this here gets executed, and else it would kind of mount the window, but then it would somehow continue after mounting a window, and then yeah, it would just return, but then I would somehow have to return to this function again, and yes, and that's why I just make async call this async send as soon as yeah, either of both, either I have a selected something in the menu, or if I have asynchronously sent something, or if I haven't passed any have passed arguments, it will be sent here. Yeah, and the other thing used is also here. There's also asynchronous reading and writing of files. It opens the file. Yeah, it kind of has to get the directory of this example files here, and yeah, and then there's this callback function that's over here, and this callback function gets an error if this open wasn't successful, and else it receives this file handle, and then this file handle can be passed to this fstat, and fstat is to get information about the file and also know if it exists, and then here it also has a callback function, and then you have callback function and a callback function, and yeah, and if I wouldn't implement it this way, and this read would need a long time, then I would the editor would be stuck until the file is read, and yeah. Then here I get this stat, this table of information about the file. Then I get size, and I read size of file from the file. And yeah, and then there's also to close the file asynchronously. And yeah, and this callback function only gets called once the file is opened, and here also only once the file is read. And then after that, the execution can just continue after this. And once it is read, this callback function, or opened, the callback function gets called. Yeah, that's kind of a different ways of asynchronous reading and yeah, asynchronous code execution that I used for this plugin. Yes. And have I forgotten anything? I mentioned schedule wrap. The state machines. I maybe stop for a second. Yes, one thing I forgot to mention about this protocol. As soon as I correct it, it's yeah, still not completely correct as you saw previously. And yes, and what I wanted to mention is yeah, this whole protocol starts again as soon either first it starts by sending the RETI code, and then it finishes here, and then the next iteration starts by sending this command here, and that's this command that can be that's this next command. If I hit the next key, then it's goes to next cycle, and then here it sends this next and then a new line. Actually, next space, and then this gets evaluated here on this side with where is it? Yeah, it's daemon, and then here it waits for an input, and then it splits it. That's why there's the space, and then it's yeah, to have here also args, and in this case there are no args, and then here command, and then it reads next, and then yeah, then this continues over here with this loop again. yeah, then it asks for next instruction. Then this instruction can be input, read, input, or output, or something like that. And then yeah, and then it starts all over again. Yes. Yeah. Then the command executed is over. Then it goes here again. Reads in registers, relative registers, EEPROM UART. Then then we are here. Then it asks for the next instruction again. And yeah, then that will be that at the moment there's only the next command. Then here there comes the next. Then it continues with the executes the next command, and then the RETI has changed its state, and then it reads in the state, and then the next command. And right at the beginning, it will just send. There's the option handler, and right at the beginning, it will just send. It will just send in. It will just read the buffer. Oh yeah, and there's another special thing that because this input here works with new lines to know when it finishes reading, I actually have to convert the buffer that I sent. I actually have to convert the buffer that I sent init buffer. I actually have to convert all new lines into another word that doesn't contain a new line. I just call it new line, and then I send this buffer. That's what you see here. I sent this buffer, but I have to replace all new lines by new line. And and on the other side, because the input ends as soon as a new line appears, and I only sent a new line at the end. And here I have to replace our new line by real new line character again on the other side. And that's just at the beginning. Yes. This is the beginning, and after that will always be sent a next command. And this next command is just this next that you see here, next cycle, and then sends next, and that's just this shortcut, this key binding here that is bound to this next action punct next. That's for made for set for all buffers and has a description. That's basically what you see when this description here. To see if you make this, and then that's if you go to n next instruction, that's this description that stays. That's this description here. Yeah. Yes, that's about that. And and now I want to say something about the directory structure. And it is from some random Stack Overflow comment that I can't really verify. And this I know that this directory structure of NeoVim plugins that are implemented in Lua applies to this XDB base directory specification standard. Yes, but I didn't spend much time there. But basically, it works the following way: you have your plugin here, and then there's a this plugin here, and then you have this help GP, and this runtime path, and this runtime path is bound to this And this runtime path is bound, and this repository directory that gets added by lazy.nvim, cloned by lazy.lenvim, and lazy.nvim is going to add a search, is going to search for a directory called Lua in this repository directory that is added, cloned by lazy.nvim into this local share nvim lazy directory. And this directory gets added to a runtime path. That's this way it can already be found. And in this runtime path search for a folder called .lua, and that's this folder here. And there you usually create a folder with a plugin name. That's this. If you require something from there, then that's also this directory here. That's what you require. And a dot is kind of like a new directory backslash, the slash. And then you can, for example, if you go to RETI-Debugger.configs, that goes to here, and then this dot is like a slash, and then it goes to this directory, RETI-Debugger.configs. And this inner.lua has a special role. If you just require RETI-Debugger without a dot afterwards, then it just goes to this inner.lua file. And that there is usually a setup function, and that's what you call mostly. So I could also call the setup function by saying require RETI-Debugger setup. But I think this should not work because it works, but that it's already loaded by my by LazyVim because I have a configuration file for it. But yeah, I actually have to change this to opts actually. At some later point in time. Yeah, so it should look like this. And yes, that's about the directory structure. And yeah, actions is just all actions that you have a key bind. Mostly you have this dealing with errors and stuff. This applying to this protocol, and yeah, then you have this auto scrolling, this different modes, and at the bottom you have this actions that get called, this functions that get called by commands. That's why we have this M, because they get that's for public functions in Lua that get returned by as a table in the table, and they get called by this key bindings. That's why I need to be public. And yeah, then there's this whole chain of read buffer content chain, and yes, and then the function for commands, and yeah, that's all the rest of it. Yeah, then there's this .configs.lua that's just with default configs and the setup functions are if you haven't specified a command for normal option, if you haven't provided normal options, then the default options are going to fill up all spaces. That's why I have keep here that haven't been filled by your normal options. So it doesn't override anything. So yeah. And I didn't want to specify global key bindings because they can have problems with other global key bindings, because they can cause problems with other plugins. That's why I don't define global key bindings. But this buffer key bindings, they only work in the buffers and not outside of the buffers, and they override the global key bindings, and that's why I can specify them. And you can also define your own next. You can also define your own next. You can also define your own. Could also define here your own next is equal to big N or something. That's also something you could do, but yeah, that's not something I'm going to do now. And yeah, and then this here wouldn't override it, but it would keep the big N that I specified in opts that I passed to the setup function. Yes. Then I still wanted to say something. Yeah, and then there's init. There are basically only the most important functions, like to start the plugin, to restart would actually also fit into actions because it's not that necessary, but it was easier because of cyclic dependencies and stuff with requiring that to just put it here because it just calls the start function. And yeah, restart. Yeah, then you have here start, setup. So all important things that happen with the start of a plugin and the setup of a plugin. Oh yes. And global key bindings, they are only hiding that are just load example, compile, and start at the moment. And hiding is actually only as soon as the window layout starts, and that's only as soon as the start here is called. And yeah, and hiding is only going to be, yeah, I actually don't know what this is good for. Yes, and hiding is only as soon as the window layout appears and as soon as the start function is called. That is bound to this key here. This is bound to this key here, which is in turn specified here. If you specify it. And as another thing I wanted to mention is that for this protocol, in this protocol, I actually have to reorder it. It optionally sends the output message, and if it stumbles upon a print, if a print statement is executed, like what am I doing? If a print statement is executed called print register, and in this case, in this communication loop, there you sent a command that was handled down here, and then this loop continues, Where is this? I hated to search things in here. Not again. And then it just continues with this loop here, and if it stumbles upon such a print statement, then this print statement will write something, will write output, and then the register value here into here, and then the RETI-Debugger plugin has here, before starting with this loop, starting to look if registers arrived, it this reads start function kind of collects everything until something stops it, and then it reads this output of this call print rec first, and then it continues reading the registers, and then this output dot value, and then a new line, then a new line, and then registers after all after another. That all will be within this data variable, and then I just have to check if there was a if there in this data there stays a output in the first line, output colon. I could actually just read the but I have to change. I could make it more efficient by just reading until the new line and then look if there's a output. But anyways, not relevant at the moment. And then it will display a. It will display this output by just reading it from the data, and that's what you see. And then it calls this output window and writes into this buffer the value that you want to have here, and it sets the proper key bindings for this buffer. Because there's in every round a new buffer, it has to constantly, and also if you hide a window, you constantly have to, because it's bound not to a window, this key bindings are for the buffer and not for a window, you kind of have to do it every round, and again, because there's always a new buffer, and the key bindings are bound to the buffer, not to the window. And yes. And then as soon as it has displayed the output, it just it returns the data, but without the first line where this output stays, and then there are only the registers left. And that's what's going to be, and that's what is, that's what is, in this case, this return, this if that doesn't apply and it jumps over this return, then it just writes the registers as usual into this buffer, but without the first line. That's how this protocol works. For error message, it actually ends there and it doesn't continue afterwards, but it's kind of really quite similar. For error message, afterwards there comes no input anymore because the RETI interpreter has stopped in this case. So it's just a single error message, and then it just looks if there is error, because the RETI interpreter makes a line where there is a heading where it prints error, and then we have to just search for error, and in normal registers or RETI code the word error or output doesn't appear. That's why we can use it. Then go on in the automaton. A pop-up has appeared, and mount the error window, and and here one can basically one returns nil, and in case of returning nil, yeah, also here we have nil, and then it goes here, and theoretically this read start continues, but there is no data from a RETI interpreter coming anymore. That's why, yeah, it just stops, and yeah, it's finished. And input is kind of a special case where, yeah, input, the thing with input is it sends this input string. It sends this input string, and then it waits for something to write. That's why you don't have to make any thing like with output where you have to delete the first lines or something. But it's just this protocol is just a little bit extended, where you would what am I doing? We'll check if it writes input and then ask for input, and then it just next in the protocol you're kind of at that moment in time you're kind of here, and that's the place where, yeah, it's kind of a place where you're kind of you are in interpreti. Yeah, you are here. You are executing instruction. The instruction has is this call input rec, and then this protocol kinda, yeah, gets this input request, and then you send an input, and then yeah, it then the protocol just continues as usual. Protocol just continues as usual. Yeah, the protocol just continues as usual. Yeah, it goes through here, and then you are again here, and yes, and it just sends the registers as usual. Yeah, so basically I made a little mistake here, and this line just actually has to go to here, and then it doesn't have to be, and then it actually, yeah, it kinda has to be here instead, another option instead of command. That was my mistake. And then this protocol just continues as usual, but no, it's a little bit, yeah, then it sends here the registers immediately. Yes, that's something I have to change about it. It has to go here, then input, and then it has to be another registers possibility to, yeah, this is something I have to change. Yeah, and another thing I wanted to mention is, that's the last thing I want to show, is the following. I also implemented something new to the RETI interpreter. If I execute this example, you see that I will be asked for input, but it's also possible to provide metadata in the comments of the RETI file, and that works the following way. Therefore, I have here RETI metadata, and it just reads there's this regex, and from this regex it extracts the values. And what you can therefore make here, you can just write here 42 or also space. It's really, or you can also make this or something. Want it to be as convenient as possible. Yeah, and also you can also specify the data segment size. I make it to 64, and then then it will read. This time it made it not previously it was only 1, only had the size of 1, and now now it has the size of 1, and now I changed it to 64, and it has now much more space. And now it won't ask me for input anymore because it already has the input, and it will also only output the print the output. I can restart, and it won't ask me for input anymore because I specified it in the metadata of the instruction. Now if I make it, one again, the data segment has only a size of 1 again. I guess that's all I wanted to show. Now I have really shown everything I wanted to show. Then thank you for your attention, and I hope you have fun with the plugin, with my RETI-Debugger Neowin plugin. I really made this recording with my last bits of concentration I had. So bye.